Good morning everyone. In this session, let us continue the same unit 4, that is learning. In this learning, today let us discuss about the artificial neural network, or simply we call it as ANN. Let us discuss what is this neural network and how we are going to relate it to the human brain processing system, and what are the different types of neural networks like single layer feed forward networks and multi-layer feed forward networks. And coming to this neural networks, we know that humans have an ability to identify patterns within the accessible information with a high degree of accuracy. Similarly, ANN also related to that are computation systems that need to imitate human learning capabilities via a complex architecture that resembles the human nervous system. Human nervous system, we know that it consists of billions of neurons, and these neurons collectively process the input received from sensory organs, and that it is going to process the information and decides what to do in a reaction to the input. Similarly, these ANN or artificial neural networks are inspired by the human neural network architecture. So see here, our human brain processing system, we have three important elements. One is dendrite, cell body and axon. Dendrite is nothing but a input to a neuron, and cell body is here, information processing happens here, and next axon is output to the neuron. Similar same structure, if we go for the artificial neural network, it is similar to the same human brain structure, where this particular dendrite is nothing but the input layer, and the cell body, which information processing happens here, is the hidden layers and the output layer. So by seeing this diagram, one can understand that artificial neural network consists of three layers. One is input layer and number of hidden layers and one output layer. Let us compare these two. We can see these two diagram and we can think that how similar they are. Input to a neuron is input. Information where it is processing happening here is done in the hidden layer, where we are going to extract the features, and then output to the neuron we are going to get the output. In this, ANN is similar to the human brain processing system. Then what is this neural networks? How we are going to define this neural network? Neural networks are nothing but the computational models inspired by the human brain. They consist of interconnected unit or nodes that we generally call it as neurons, organized it into layers. Previously we have seen that diagram, that is organized it into layers. And neural networks are capable of learning from data and making predictions or decisions without being explicitly programmed. So this the same example, this is human brain processing system and this is the artificial neural network system. And coming to the neural networks, we have two words here. Then what are neurons and how they are connected? So neurons are nothing but the basic building blocks, and they are also called as a mathematical function that process input data and produces an output function. And how they are connected? Here they are connected to other neurons through connection. These neurons are connected to the other neurons, and each input is assigned a weight, and each connection have associated weight that determines the strength of the connection, and during training these weights are adjusted to optimize the network performance. The weight determines how much the output of one neuron influences the other neuron. So there is a lot of importance is given to a weight in a particular artificial neural networks. And see this is the structure of a artificial neural networks. See here, these are the inputs. Each input is having the corresponding weights, and we are going to summation of this input with weights, and a term called as bias is added, and the result of this particular thing is called as the activation function. So this sigma represents one of the activation function, and this whole thing is called as a neuron, and it is going to give the output. Whatever the activation function gives, that itself is the predicted output. And this is a simple neural network where we have an input layer, one hidden layer and one output layer. A simple neural network consists of single input and single hidden layer and single output layer. And let us see what are this input layer. Also known as input nodes, are the inputs or information from the outside world is provided to the model, and this pass the information to the next layer, that is called as the hidden layer. And coming to the hidden layer, it is also a set of neurons neurons where all the computations are performed on the input data, and there can be any number of hidden layers in a neural network, and the simplest consists of only single hidden layer. And next one is the output layer. Output layer is the output or conclusions of the model derived from all the computations performed between input layer and the hidden layer, and there can be single or multiple nodes in the output layer. And if we have a binary classification problem, if the ANN is used for binary classification problem, the output node is 1, but in the case of multi-class classification, the output nodes can be more than 1. We know that binary classification we have 0 or 1, but coming to the multi-class classification, it may be more than 1. That's why, so in binary classification the output is 1, if it is multi-class classification it may be more than 1. That is what the output layer. And coming to one more important concept in ANN is perceptron. So what is this perceptron? Perceptron is nothing but a simple form of neural network, and it consists of a single layer where all mathematical computations are performed. You can see this particular architecture and compare this architecture with the previous architecture where we don't have any hidden layers in this architecture. Only we have the inputs and the corresponding weights that will be given to an output. Summation of this will be we are going to get the output. So this is called as the perceptron. It is a simple form of neural networks and consists of only the single layer. And these ANNs are inspired by we know that human neural network architecture, and the simplest neural network consists of only one neuron and is called as the perceptron. The same thing, one more way I am defining what is this perceptron. That is like this, this particular diagram represents that it is a perceptron. Why? Because where we have only the one neuron, and directly we are going to summation of this x1 into weight, and that we are going to give the activation function and we are going to get the output. So this is called as the perceptron. A perceptron, one input layer and one neuron, and the number of nodes in the input layer is equal to the number of features in the input data set. So the number of nodes, how we are taking is the number of features in the particular data set, and each input, as I said, it is multiplied with a weight and the results are added together. So what is that weight? Which is typically initialized with some random value. Okay. The sum is passed through an activation function, and the activation function of a perceptron resembles the nucleus of human nervous system neuron. Okay. And it processes the information and it is going to yield an output, and in case of this perceptron the output is the final outcome. So when we take this perceptron, the output itself is this output itself is the final outcome. And whereas we have other type of perceptron, that is multi-layer perceptron, also we call it as simple artificial neural network, consists of more than one hidden layer. So just compare this particular diagram with the existing one. In perceptron we don't find any hidden layers, directly input and we are going to get the output. But where in multi-layer perceptron we'll have n number of hidden layers. That is what the difference between single layer perceptron and the multi-layer perceptron, and these hidden layers are grouped together to form a multi-layer neural network. So by seeing the architecture itself we have to identify whether it is a single layer neural network or multi-layer neural network. In the above diagram, the ANN consists of 4 layers interconnected with each other. An input layer, if you see this, it consists of 6 input nodes, okay, and hidden layer 1 with 4 hidden nodes or 4 perceptrons we call it as, and hidden layer 2 also it is having the 4 hidden nodes, and output layer with 1 output node. In this way we are going to describe the multi-layer neural network. And next, this is one just a diagrammatic representation of deep neural network. A deep neural network is a simple neural network that consists of multiple hidden layers. In the previous one we have seen only 2 hidden layers, but we have here n number of hidden layers. So if you are using this many hidden layers, this particular architecture generally we call it as the deep neural networks, or simply we call it as the DNN. And this is one architecture of this ANN, where we have inputs, associated weights, and we are going to summation of this x1 into w1, and a bias term is added. That is what the artificial neural, and these are weights of connection w, x1 are the inputs and b is the bias, and this is the activation function, and this itself is the output. This is general how a process will go in the artificial neural network. So weights are here, These weights and biases are fundamental components that influence the model's ability to learn patterns and make accurate predictions. So to predict some accurate predictions, a particular neural network, we have two important components, that is weights and the bias. And the same thing, neuron, it is the basic unit of a neural network, and it receives inputs, processes them and produces an output. And we have three layers, one is input layer, hidden layer and the output. And we also have a weights and biases, that is the connection between neurons have weights that are adjusted during training. After getting output, we are going to compare the actual output with the predicted output, and if the error is more, we go back and we are going to change the weights. And each neuron also has a bias term to shift that activation function, and these two are to be compulsory included when we are implementing some application with the help of artificial neural network. And coming to the activation function, it determines whether a neuron should be activated or not. So this also plays an important role in the neural networks. And weights and biases together control the outputs of neurons and behavior of the network. And one more thing, weights determines the significance of inputs in a neural network, while biases help the network adjust its output more flexibility. For input we require these weights, and for output we require these biases, and both are key to ensure that the model can accurately learn from and generalize to new data. Okay. Then see this one more type of this same neural network, but till now what we have discussed, the process, input, weights, and adding of multiplying input weights and adding a bias term, then applying an activation function, and we are going to get some output. So that particular process is called as the feed forward network, or else simply we call it as the forward propagation. And if we find error and if error is more, we come back and we are going to change the weights. That particular thing we call it as the back propagation. So forward propagation and backward propagation are important concepts in this neural networks. So here, in the very first step, the input units are passed, that is the data is passed with some weights attached it to the hidden layer, and we can have any number of hidden layers, and and the inputs, let us take the previous examples, that these x1, x2, x3 are passed, and each hidden layer consists of neurons, and all these inputs are connected to each neuron. And after passing on the inputs, all the computation is performed in the hidden layer. How the way the computation is performed is in the hidden layer. And how it is going to perform computations in hidden layers are done in two steps. Okay, let us discuss that in detail in the coming session. Thank you.